Hello, in this video we will be studying about radius of gyration. First we will give the definition of radius of gyration. Radius of gyration is defined as the distance of a point. So basically it is a distance of a point at which the entire mass of the body can be said to be concentrated, having moment of inertia same as that of the body. That is, the point is having same moment of inertia about that axis. That moment of inertia is same as the moment of inertia of the body. The idea is the point's moment of inertia is same as the body's moment of inertia. Accordingly, the distance should be considered. So, having the moment of inertia same as that of the body with actual distribution of mass. So, how to find radius of gyration? What is the method to find radius of gyration? First, you write the expression for moment of inertia of the body. Then you equate it to mk squared. M mass of the body and k is the radius of gyration. So moment of inertia equate it to mk squared, solve for k, which will give you radius of gyration. So method to find the radius of gyration for any body, write I equal to mk squared. I is the moment of inertia of the body, where I is the moment of inertia of the body, which is, that is given here, and k is the radius of gyration. Okay, so this is the body, axis, m is the mass of the body, this is the axis, moment of inertia of the body about this axis is I. So now what you should do, condense the whole body into a small particle, or imagine it so, and the particle is placed at such a distance that moment of inertia of the particle about this axis is same as the moment of inertia of the body about this axis. Okay, so see, now this is a particle, or you can even say a point, whose distance from the axis is radius of gyration. The mass of the point or the particle is same as mass of the body. So mass of the body is said to be concentrated here, and it is to be placed at such a distance that the moment of inertia of the particle about this axis is same as the moment of inertia of the body about that axis. Okay, there is one more definition. Radius of gyration is also defined as root mean square distances of the particles from the axis. See, k is equal to square root of r1 squared plus r2 squared plus r3 squared etc. up to rn squared by n. Root mean square, no? So it is root mean square distances, root mean square distances of all the particles of the body from the concerned axis. Okay, yeah, we will see few examples now. Radius of gyration of a thin uniform rod about a perpendicular axis passing through its center. This is the rod, axis about which we want radius of gyration. L by 2, L by 2. L by 2 is one side length, that is from the axis to the left. L by 2 is the length of the rod to the right side of the axis, meaning total length is L. I just wrote L by 2, L by 2 just to know where the axis lies exactly. Okay, now the moment of inertia of the rod about this axis, ml squared by 12. So equate it to mk squared. Here you can cancel the two m's, one on the left side, one on the right side for this equation. What remains is L squared by 12 is k squared, or k squared is L squared by 12. So k will be L by root 12. That is radius of gyration in this case. Root 12, if you want, you can write as 2 root 3. So this is the radius of gyration of thin uniform rod about a perpendicular axis passing through the center. Next example, uniform ring, radius of gyration of a uniform ring about a diameter, uniform ring diameter. So this is the axis, okay. We want to find radius of gyration of the ring about this diameter. First, write the formula for moment of inertia. R is the radius of the ring. So mr squared by 2 is the moment of inertia of the ring about its diameter, equated to mk squared. Cancel this m. So k squared is r squared by 2. So k is r by root 2. This is the radius of gyration in this case. Next example, radius of gyration of a solid sphere about a tangent. Solid sphere, radius r, axis. So write moment of inertia equated to mk squared. Is it clear? 7 by 5 mr squared, moment of inertia of the solid sphere about a tangent. 7 by 5 mr squared equated to mk square, cancel m. So k is equal to root 7 by 5 into r. One more example, radius of gyration of a solid cylinder about a perpendicular axis passing through its center. Solid cylinder, axis about which we want to find radius of gyration. Write the moment of inertia expression. So this side length L by 2, that side length L by 2. So total length is L. L is the total length of the cylinder. Okay. Now as usual, write the expression for moment of inertia equated to mk squared. So k is equal to understood this? Thank you.